So we're given a function here. We need to prove if it is continuous or not and explain it. And they ask us if we can remove the discontinuity here of the function, or in other words, how would we redefine this value at x is equal to 1, right? It means that the second range here, to make it a continuous function. Okay, so in order to prove this, we need to go back to the definition of a continuous function, right? Do you remember the three conditions of a continuous function? A function is continuous at the point if it is defined on that at that point. Right. And the second condition. So the second condition, what is it? The limit of that function when x approaches a should exist, right? And the third one, what is it? The limit of this function should also be the same as f at a. If it is satisfying all these three conditions, then the function is continuous at that point. And the point we're considering here is the point 1, right? Is this function defined at 1? Yes, we're given here, right? So we're given, according to the definition of this here, f of 1 is equal to 3. Okay? Then, therefore, the next step is to check if it's satisfying the second condition, right? So here, the branch function, it means that if it is a real line here, and the point 1 here. So if the function is smaller than 1, which branch should we use? This guy, right? And if a function is larger than 1, we should use this one. Then in order to prove the limit exists, we need to compute the left-hand limit and the right-hand limit. The left-hand limit of the function f of x here, when x approaches the point 1 from the left. Since we are taking the limit from the left, it means x is smaller than 1. Therefore, we use the definition of the left branch, which is this branch, right? Then we replace f of x by x plus 1. It becomes limit of x plus 1. Is it clear why we have this? Okay, very good. And what is the limit of this guy? Ooh, be careful. 2. Very good. Thank you, Isaac. So limit of this is a polynomial of degree 1. Then it is continuous. We can, just replace and use the limit rules. It would be the limit of x plus 1 here, limit of 1, which is 1 plus 1, and it is 2. That's it. Okay. Second, we need to find the right-hand limit of f of x. Or in the exams, you don't have to write this much. You can simply write, okay, right-hand limit. Okay, save you a little time. I'm okay with that. Then do the same thing. Okay, compute the limit of the function f of x as x approaches 1 from the right-hand side. Then from the right-hand side, we use the definition of x is larger than 1, which is x squared plus 1, okay? And what is it? Yes, it's also 2. We use, or let me write the step in details in this case. Limit when x is approaches 1 of x squared plus the limit of x approaches 1 of 1. Well, finally, it is the same. It is 1 plus 1 squared plus 1, and it is 2, right? Very good. The left-hand limit is equal to the right-hand limit. Therefore, left-hand limit is equal to the right-hand limit. Therefore, limit when x approaches 1 of the function f of x is simply equal to 2. Okay, we conclude this. In other words, it satisfies the second condition of continuous point, continuous at this point. So the only thing, however, the third condition, is it satisfied? As we know, f of 2 of 1 is equal to 3. It is defined above, right? So in other words, the limit of the function f of x as x approaches 1 is different from f of 1. Therefore, it is discontinuous at the point x is equal to 1. Okay? No. So that is for the question A. We explained already. Question B, how would you remove the discontinuities of the function? In other words, how would you redefine f of 1 in order to make it continuous function at 1? So we can remove discontinuity, the discontinuity of the function at x is equal to 1 by redefining the function value, redefining the function at x is equal to 1. And in order to satisfy the third condition, in other words, we should define f of 1 is, what is it? Thank you. Is that? Then if we define f of 1 is equal to 2, then it is the limit of the function when x approaches 1, right? That's it. So this notation in math, it means define, okay? That's it.